This topic belongs to chapter 11, but instead of using author provided PowerPoint, I'm using my own. The topic is streams and files. So data representation. So data can be encoded either in text or binary format. So text format means when you deal with the data, especially here is a character. Each character by character, the corresponding assignment, ASCII traditionally, nowadays Unicode, that value is stored into a file. So for example, if you want to store character C, then character C is the ASCII value or Unicode value is stored. Another example is if you want to store number 12, then digit 1 and digit 2 are stored using the ASCII or Unicode value. That is called a text format, and of course the benefit of a text format is that it's a human readable. But the binary format, you do not go through such a mapping. Mapping here means a text format. You do mapping into ASCII table or Unicode table to actually store the data. But binary format, you don't do such a mapping. You try to store the value directly as the language defined. In character cases, there's a little difference. In binary format, if you want to store character C's Unicode is stored because Java uses Unicode for char type. But when it comes to the number, there's a big difference between text format and binary format. In text format, to store number 12, you store digit 1 and digit 2 separately according to ASCII or Unicode table. But in binary format, number 12, the value is stored into file directly depending on the number 12's data type. Suppose if it's an integer, then Java uses a 4-byte signed integer as a representation. So number 12 is converted to 4 bytes binary number, and that is stored into disk file. So that is a binary format. So in detail, the text format, text data is stored using Unicode or ASCII code. Traditionally ASCII code, nowadays many programs support Unicode as well. Since Unicode is a standard character set universally used, and then there are many text editors, so you can browse the contents by through the editor, so it becomes a human readable. So to facilitate reading and writing data one line at a time, the text file is organized using something called a new line character. So physically, new line character is shown on the screen as a next line instead of some other special characters. So that facilitates reading and writing. So here is an example of a text format data. Suppose you store Bob blank 2222, the Paul 5555 in text format. Suppose this is a Unix environment where the ASCII character set is used. Then uppercase B's ASCII value in 8-bit data, and lower b, and then one space character, and then 2 as each digit. And then since we have a new line here, so new line character, and then PAUL 5555 at the end, the new line. So these are the text format data stored this way. So each character we go through mapping. For this case is ASCII mapping, and that the mapped values are stored in the file. Binary format uses the language's native storage scheme. So we are dealing with the Java, so Java's native storage scheme is used. It does not go through mapping process. So binary file does not facilitate any writing or data, reading data one line at a time, since there is no concept of a new line. But Java provides a method to write for each data type, char type or double type or float type or boolean type and the like, and so there's a corresponding method call to deal with those binary data. So here is an example. If you want to store Bob and this number in the binary format in Java system, each character is a 2 byte Unicode. So uppercase B corresponding Unicode value is stored in 2 bytes, and then lower O and lower B, and then this is a one integer number. If it were text format, for each digit you are going to store with the corresponding mapping value, ASCII or Unicode. But here is a binary, so this is just a one integer. So this value in Java native representation is 4 bytes, and this is the corresponding binary value. So this big number is stored in 4 bytes in Java's native integer definition. So comparison, benefits of a text format is of course it's a human readable, but problem with or disadvantage of a text format is that for each character you go through mapping process using ASCII or Unicode. Especially if you want to deal with the numbers, then it becomes slow. For each digit, it has to be converted to ASCII or Unicode value. But in binary format, since we don't do any such mapping process, so the process is faster compared to text format. So here is an example how to write data into disk file using text format, but this is not the only way to do so, but I'm showing you one of the way to do so. So here typically we have a pair of classes to deal with a lower level interface and higher level interface. So to write data as a text format, so low level is a file writer where you specify name of the file to be created, and then wrap it by print writer class, and then you have the object. This object is very similar to system.out.println. If you do system.out, the data is printed, displayed on the screen, but if you do here out with the println, then the data you specify will be stored into a disk file. Of course, when you do a file writer and print writer, there's exceptions that are thrown, so there are checked exceptions, so you have to do catch block, and then finally close. You can close the open the file stream. Next example is how to write a binary format data into disk. Another pair of classes are used. So low level interface is a file output stream, and this file is to be created, but you wrap up this object with data output stream. Then data output stream provides a method for each data type from the Java language. So if you do write 1 byte and write int, write a double, write float, write the char, and so on, for each data type there's a corresponding method call. Then you store those data in a binary format. Of course, we have some checked exceptions thrown, so you need to do catch block, but in the finally close, you can close the open the stream. Another case is the read file, which is in text format. Then another pair of classes are used. File reader is a lower level interface, so here is the existing file name, and that object is wrapped by BufferedReader, and then using BufferedReader, then you can read one line at a time, and Java does not provide in much detailed process. So what you need to do typically is that read one line at a time and then parse it. If you are expecting a double number, change it. If you are expecting two integers with a blank separated, then from this line you need to process that. Of course, we have checked exceptions thrown, so you need to catch them properly. So here's another example how to read a binary data from disk file. Another pair of classes, a file input stream, which is a low-level interface. So existing file name is in.dat, so from which you are going to read. And then data input stream is a higher level interface, so you wrap the low level ones into that, and then for each data to read, you have a corresponding method. If you are going to read 1 byte, so read 1 double, 1 float, 1 boolean, 1 char, and so on. So there's a corresponding one. So here you should call the matching one as you have written them. So if I go back here, when you create the binary file, you have used the write int, write double to store some different data types, and then when you read it, you should use a corresponding matching method to recover the data without any corruption. And then Java has another very convenient or interesting file I/O, one that's called the object file I/O. So the problem is that in most object-oriented program, the data are in object format. So object has some instance variables, and those are the data. But in disk file I/O, either text file or binary, it's not based on an object, but it's based on each individual data type. So storing the huge set of objects, not individual data types, are a little bit challenging one, but Java's solution is object file I/O through serialization service. So what it is that when you declare or define a class that has to be stored in a disk file, then use a serialization service. That service is very simple to get. All you have to do is in a class definition, use a serializable interface implemented, and then serializable interface does not have any abstract method at all. So even if you implement it, you have no responsibility to implement any methods defined there. So all comes free, and then JVM, Java Virtual Machine, handles all the details. So here is an example. Let me show you the actual code. So suppose I'm going to use a huge set of a student object, and then I need to store into disk file so that I can restore and recover it later after the program quits. Then all you have to do is when you define student class, implement a serializable interface. That's all. And then you can easily store the student object's state into disk file and recover it easily. So how do you store into disk file? Here is the example. Suppose I have a student array, and we have many students, then I want to store each student states into disk file, and then I want to later read it. So here how to write is given here. So what you need to do is again use a pair of classes. First a file output stream, then you are going to create a new disk file named students.data, and then wrap it up by object output stream. Then object output stream has a write object method. The write object method you provide one collection. Here is array list. Then everything inside this collection will be stored into a disk file by one method call. So you don't have to worry about how complicated each object is. So just one simple method call takes care of storing all the objects within this collection. So by executing this code, you have a students.data disk file created. And once the program quits, so sometime later you want to restore all these values as they are, is demonstrated here. So what you need to do is use another pair of classes, a file input stream, specify the file created from earlier demo, and then wrapped by object input stream. Object input stream has a read object method. Then all the data are restored. So what I have stored in students data is array list of students, so you can typecast it back to the precise type you have stored, and then this becomes exactly the same contents where you stored that. So by simply calling one method, the collection is recovered. No matter how large the collection is, it does not matter. Simple one method call handles that. Now you can display that to actually verify all of those from here is correctly restored. So this is a object file or IO system. So this is a very powerful and convenient feature to store the states of a huge set of objects.